Hi, so I'm gonna go through how to load image data or images into Python, how to explore the dimensions of said image, so how many channels does it have, the X and Y dimensions, how many pixels that is of that image, then how to grayscale images, which is picking a particular channel, and then also how to crop images based off slicing pixels out of your image array. And then from there I'm going to show you how to save those images for later analysis. So the first thing you need is to install a module into Python which allows for loading in images, and the module we're going to pick is this Scikit image, which is a module which has it's a collection of algorithms for image analysis. And if you look at the documentation for this module online, you see that it has some fantastic tutorials in its own for how to use it. So first thing is to do your pip install either in your terminal, pip install Scikit image, or if you're using PyCharm, you can go up to the top, settings, go to interpreter, click this plus here, and type Scikit. There it is, Scikit image. Click install, wait for it to install, and then you have essentially what you need for this tutorial. So the first thing we're going to do is we're going to, from Scikit, well, Scikit image contains Skimage. Skimage is maintained within Scikit image. So the first thing we need to do is when you've successfully installed Scikit image, you have Skimage. So from Skimage, we're gonna look into its I/O, which is a collection of utilities for reading and saving images. And from Skimage I/O, we're going to import image read. Nice and simple. So from there, let's get that code running. Yes, it's run. It hasn't screamed at us. So for this video, we're going to work with this example image, which is with an image of two Drosophili, mutant Drosophili, where the first thing we're going to do is just trying to load this image into Python so we can explore the dimensionality of it. So to do that, we declare a variable which we're going to call image, and then we're going to use the image read function, and this image read function requires a path, an absolute path to your image. If you're using PyCharm, you can get the absolute path like this. Just click it, copy it in, and run. And it seems to have worked. So we can check first. Yes, when we type in image, we get a printout of an array, which is our image. We can check the basic information of this object. So should we see what type it is? Yes, it's an array. And if we look at the shape of this array, we see that it's 1200 by 1200 by 3. So I'm going to explain what those numbers mean. So I have prepared a image which shows image dimensionality here. So this is it. It's this PNG here. I'm going to copy the absolute path, just like what we did for our data. I have it. Now, to show the image, we're going to use another library called matplotlib, and we're going to go into pyplot within that, and we're going to save it as plt. And this is quite standard. And then using plt, we're going to use img.shape. We're going to put the image that we want to see. and see if this works. There we go. So this image shows the data structure of a typical RGB image. So if you look at our image shape, it gave us these three numbers. So what it's saying is that on the y-axis, which is this number, we have 1200, this column has 1200 rows. And then the next 1200 is saying that we have 1200 columns. So the image is 1200 by 1200 pixels. And then the last number that we get from the .shape function is 3, and this is referring to the channels if it's an RGB image. And we have 3 channels. We have this XY array in red, in green, in blue, and when they are combined, that gives you a normal bright field colored image. Okay, so these numbers make sense to us now, what they mean. This image is 1200 by 1200 pixels times 3. So what we could do is, a typical thing when you're analyzing images is that you take one of these channels and you grayscale your image based off one of those channels, and you can do that very easily in Python, and this is how you do it. So firstly, let's just check that our image is what we think it is. So we do image show. Let's put the image that we prepared earlier, and let's have a look at it. Yes, so this is the original unaltered image. Good. Now I want to grayscale it, let's say from the red channel. So to do that, it's quite easy. So image red or image gray will be the image sliced. Sorry. So I want to keep all of the Y pixels. I want to keep all of the X pixels, and I'm going to take the first index of the channel dimension. And I do that, and if we check the shape of our image, and you can see is from the original image, which had 3 dimensions, we now only have 2 dimensions. And we can visualize this. We can see what we got. Oh, and we have a weird color map. So let's just put that into gray because it's easier to visualize, or to make sense of what we're looking at. Gray. There we go. So we have reduced our array size down from well, it's 33% smaller now because we've taken a third of the data, and we're left with this image. But let's say we want to go further, and we reduce the channels down to 1, but we're not interested in both of these flies. We just want to make a new image, but we just want this fly on the left. And to do that, it's just as easy as making the image grayscale. So to do that, what we do is we're gonna make a new variable, which we're gonna call red cropped. So just a point here is, when you're doing any image analysis, you're probably gonna do 10 or 20 separate operations on the same data frame or the same image. So a nice convention to get into, which I think is probably best practice, is to, in the variable name when you're outputting something, is to keep a record of the operations that you performed on that set of data. So here I have the record that I have the original image, but then I took the red channel, I grayscaled it, and then I'm going to crop it. So image red, and then I'm going to slice it. So if we look back to the image, if we want the fly on the left, if you look on the y-axis, we need the fly seems to start around about 300, going down to about 1000. So we can say that. We can say, can you give me the pixels which are between 300 and 1000 on the y-axis, and then on the x-axis we can see that the fly is actually cut off. So we're going to start from 0, because that will contain fly, all the way to about 500. So same thing again. And remember, we don't need to specify anything for the channel dimension, because we've lost the channel dimension on this this image here, because we grayscaled. So if I do that, it's worked. Shall we visualize what we have, our cropped image? So we do that like this. So we'll have a look, and yes, this is lovely. We've cropped, we've taken the pixels that we want, that we care about, that contain the object that we're interested in. Here is the fly on the left, male, and we got rid of everything that we don't want. And you know, if I was being, you know, particularly anal about this, you could probably shave off another 50 pixels from the top, and to do that is nice and easy. So from 300, let's add another 50 pixels from the beginning. And what you see is, yes, we have a nice tighter bounding box around the object that we care about. So now I'm quite happy with this this fly, this image, the cropped image that I got now. I want to save this because I want to present it to someone. I want to show someone, oh, look at this particular fly I took a picture of. Isn't he lovely? So to do that is nice and simple. We can just use the matplotlib.pyplot module. And it has a function called plt.imsave, which saves an image. And all you have to do here is you need to specify the path, the location in your folder, in your directory that you want to save your image, and the name of the image that you want to save. So I'm going to save it in the same location as the original image, but then I'm going to call this image red cropped, and I'm going to save it as a PNG, for example. I need to specify in this function what I actually want to save, what data I want to save, so I just put the variable name here, which is the image red cropped. And finally, when I look at it, I like seeing it as gray, the pixels as gray, so I'm just going to put gray here. Oops, typo. So I'm going to do this function, and now in the directory that contains my original image, I should have an image which is image red cropped. So let's just check my folder. So yes, I have image red cropped, and you can see this is my original image, which was a JPG. And what I've done now is that I've grayscaled it. I took the red channel and disregarded the green and the blue. I cropped it so I have a single fly in the image, and I've actually changed the file extension, so it's a PNG now, as easily as writing PNG. So that's it. That's how you go from one image, reading into Python, manipulating the dimensions by cutting some dimensions out or slicing, and then saving your subsequent file into your folder.